Good morning. Welcome to our next GATE video series. Myself is Krishnaveni, Assistant Professor, Department of Information Technology. Today we are going to discuss about the subject data structures and algorithms. Under this subject we are going to discuss about the topic graphs. So before going to the topic graph, we are going to process GATE examination. We know the syllabus of CSE department. Under this syllabus, we have more weightage on data structures and algorithm comparatively other subjects. Yes, so it is having a more weightage of 120 points in this subject. So we have to give so much concentration for this DS. Under this DS, today we are going to discuss about graph. So what is graph? Graph is called as a non-linear data structure. So data structure is divided by two. This is linear and non-linear. Linear means it is having a sequences of arrangements of data, but in non-linear means the data should not having the arrangements of linear manner. It may be in the form of tree or graph. So today we are going to talk about graph. Graph in data structures or non-linear data structures made up of a finite number of edges or vertex. Edges and vertex. So vertex is also called as node. A node is in every graph and tree. It is a node. They should be connected by edges. For example, if A is a node or vertex, they should be connected to another one node B using the edge. So in graph, it is having a two terminology. This is vertex or node, and another one is edge. Graph is an important concept which comes under to competitive exam like GATE. So already I told you in data structure they are having a more weightage comparatively other subjects in GATE syllabus under CSE. So you give more concentration on data structures and algorithms, and also graph is also having a more weightage in related questions. So today we are going to discuss about what is graph, components of graph, basic properties, types, DFS, representation of graph, and finally we are going to discuss about previous year's GATE questions under the concept of GATE. Okay. So first, what is graph? So this is a basic definition of the graph structure, graph data structure. So graph is a non-linear data structure. I already told you non-linear means it does not having any sequences of arrangements of the elements. Here we are having the edges and node for the arrangements of data. Non-linear data structure consisting of vertex or nodes and edges. The vertex are sometimes also referred to as nodes, and the edges are lines and arcs that connect any two nodes. So graph, you can see the diagram. This is a graph representation in the form of figure. So this 1, 3, 5, 4 is called as node or vertex. Then each node or vertex should be connected by the edge. This line is called as edge. So in this pictorial representation is graph. It have 1, 3, 5 and 4 is called as node or vertex. This line is represented as connected edges. So hope you understand the definition of the graph. So graph is a non-linear data structure. It consists of vertex and edges. It is not having a sequence arrangements of data. So more formally, graph is composed of a set of vertex. So in that diagram, set of vertex. This is 1, 5, 3, 4 is called as vertex, and a set of edges. The line represented as edges. It is used for connecting two edges. The graph is denoted by G in bracket B, E. So V is called as a set of vertex or set of nodes. E is called as edges. It is used for connecting a particular two nodes or vertex in a graph. Okay, this is a graph. So next we are going to discuss about basic components of graph. So in definition we came through the term, this is node or vertex, second one edge. What is vertex? Vertex are the fundamental unit of the graph. Sometimes vertexes are also known as the vertex or nodes. Every node or vertex can be labeled. In the diagram we can see it is labeled as number. It may be labeled as character also, A, B, C, D, 1, 2, 3, 4, anything, but it is labeled or unlabeled. Edges. So edges are drawn or used to connect two nodes of the graph. It can be ordered pair of nodes in a directed graph. Directed or undirected, it may be having a direction of one particular vertex to another one particular vertex, or it may not be having any direction. Okay. Then basic properties, basic terms came through this graph concept. So first one already I told you, vertex, second one edge, and also third one weight. Weight means in a particular graph the connected edge having some number that is denoted as weight of the two vertex. For example, you can see this is a graph. This 1 and 3 is connected using the edge. This edge is sometimes having some number, 3 or 4. This is called as weight. Okay. So weight can be assigned to one edge, representing the cost or distance between two vertices. A weighted graph is a graph where the edge have weights. So this weight, this particular number, this particular numerical value may represent cost or weight in between these two vertices connected using that particular edge. Okay. Then degree. Degree of the vertex is the number of edges that you connect towards. So how many edges can be used for connecting a particular vertex is called as degree. So we will come in next examples for this degree. So in a directed graph, the in degree of the vertex is the number of edges that you point to it, and the out degree is the number of edges that is started from it. So in degree and out degree we can give a numerical value how many nodes are connected in a particular edges. Then path. A path is a sequence of vertices that are connected by edges. Particular path, how many nodes are connected using this edge. A simple path does not contain any repeated vertex or edge. So in pictorial representation we can see 1, 3, 5, 6, this is the node that should be connected to the edges. We can create a path. It start from 1, then 3, then 5, then it's end with the node 6. This is the path of the traversal. Then cycle. So sum of the edges, if you are going for a directed graph, it start from some node, then again it come back to the same start node, then the graph is called as cycle forming graph. So cycle, then connectedness, all the graphs are connected using the edge, then the graph is called as connected graph. Then bipartiness, this is each node or each vertex should be divided into set of group. Each node's edge is not connected to another one node. This is bipolarities. So we can come all the terms for next pictorial representation. So basic properties: vertex, edge, weight, degree, path, cycle, connectedness, and also bipartiness. So types, next we are going to see about types of graph. First one, null graph. Null graph means this is the null graph. Only we are having the vertex or node, there is no connected edges. This is called as null graph. trivial graph means we have only one single vertex. There is no other vertex. There is no other vertex means there is no other edges. So this is called a trivial graph. Undirected graph, there is no direction. It can start from any vertex, maybe 3, maybe 5, maybe 4, maybe 1. So a graph in which edge do not have any direction. This is undirected graph. Second graph is directed graph. It starts from 3 having a direction to 1, and also 5 means it having a connection with only 3, 4 having a connection only with 1. So this is the direction of the graph. A graph in which the edge having a direction is called the directed graph. So null graph, trivial graph, undirected graph, and directed graph. This term is so important when you are come under the practice of the problems. The terms represent is a directed graph. This is undirected graph. Then only we can solve the problem based on the key term. This is directed. This is undirected. So much important the concepts under this. Second, connected graph. This is a connected graph, a graph in which from one node we can visit any other node in the graph. This is a connected graph. So 3 means we can connect 5 or 4. But in directed it can, based on the direction we can connect. But this is we can connect 3 from 5 or 4. 1. Disconnected graph. So the graph in which at least one node is non-reachable from a node. So 1 is non-reachable to 3, 4 is non-reachable to 5, but 5 can reachable to 3, 4 can be reachable to 1. But some of the nodes cannot be reached to another node because they don't having any connected edges. This is called a disconnected graph. So connected graph means it can fully communicated. So they having edges for particular 2 vertex, but in disconnected graph there is no connection in between any particular 2 nodes. They are not having edges. So next, regular graph and complete graph. This is a regular graph. It having a degree. So I already came through the degree term in basic properties. Degree. What is degree? A graph in which the degree of every vertex is equal to k. For example, if 3, you are taking the vertex 3, it having a 2 outlet edge, 5 and 1. If you are taking 5, it also having the 2 outlet edges. So 3 and 4. If we are concentrating vertex 4, it also having the 2 outlet edge. So 1, it also having the 2 outlet edge. So every node having a equal outlet of edge. This is called k degree. Here in this regular graph, k value is 2. If you are concentrating any particular node in this structure of graph, the k value is 2. This is outlet of edge. This is connecting 2. So this is called k degree regular graph. 2 regular graph. Then complete graph. Graph in which from every node there is an edge to each other node. Every node having a edge connection. In this diagram, this is a complete graph. 3 having a connection with the 4, 4 having the connection with the 1, 1 having the connection with the 5, 5 having the connection. So this all 4 vertex can be connected using connected using edges. This is a complete graph. So regular graph and complete graph. Then cyclic graph and cycle graph. This is a cycle graph. A graph in which the graph is a cycle in itself. It starts from 3 to 1, 1 to 4, 4 to 5. Again having the connection with the 3. We are starting from 3. We are come back again to the 3. While we are start, you again, this is our, in this graph our ancestor is 3. Again after completing 5 also we can take a back edge, back track to come back again, which is our start node. This is 3. It is a complete cycle graph. Another one, a graph containing at least one cycle is called a cyclic graph. In this diagram, 1, 4 and 3 is a one cycle. It starts from 1, then 4, again 3, 3 to 1, 1 to 4, 4 to 3. It is a cyclic structure. So any particular graph, it having at least one cyclic graph means this is called a cyclic graph. Cycle graph is totally different from cyclic graph. So you have to come very careful under this concepts, cycle and cyclic. So this is a complete graph, but this is not called a cycle graph, it is called a cyclic graph because it having at least one part of the graph section is cycle format, not complete graph. Here complete graph is under the concept of cycle. Okay, so this is cycle graph, this is cyclic graph. So next, direct acyclic graph, last one, bipartite graph. So this term comes for basic properties. So directed acyclic graph, this is an example. We put an arrow mark, this is, it indicates from which node to which node we are traversing. So 3 to 1 we can traversal, 4 to 1 we can traversal, 4 to 5 we can traversal, 3 to 5 we can take a traversal. So here doesn't form any cyclic, but it is a directed graph, acyclic graph. Okay, does not contain any cyclic. Bipartite graph, a graph in which vertex can be divided into two sets. So this is one vertex U, this is another one vertex B, each should be divided into some set. U is called as one set, B is called as one set, such that vertex in each set does not contain any edge between them. This U1 does not having any edge with U4, U3, U2, U1. This does not have any edge, but it having the edge connection with the another one set of vertex B. This is bipartite. So each vertex is represented in the form of set, but within the set of element doesn't have any connection. It having a connection with another one vertex set. It is called bipartite graph. So this is the types of graph. So the types of graphs we are discussing 12 types. First one, null graph. This is null, trivial graph, undirected graph, directed graph, then connected graph, disconnected graph, regular, complete graph, cyclic graph, directed acyclic graph and bipartite graph. This is all types of graph. Then we are going to the traversal. Two types of traversal under this graph like tree. This is DFS and DFS. DFS is breadth first search traversal and another one DFS. This is depth first search. First we are going for the DFS representation of the graph. So how we are going to represent DFS? DFS means breadth first search. Very clear and important one-line definition of DFS. It is level by level traversal. So if it is a tree or if it is a graph, so we are going to traversal in first layer, second layer, third layer and fourth layer. We are completing all the nodes under first level, then second level. This is the concept. So DFS is a graph traversal algorithm that should start from a source node and explore the graph level by level. First it is all the nodes directly adjacent to the source. Then it moves to the visit adjacent nodes to those nodes and this process continues until all reachable nodes are visited. So first the source node, then adjacent node, then it's adjacent node, immediate adjacent node. DFS is different from DFS, so we will discuss later. So popular graph algorithms like Dijistra's, shortest path, Korn's algorithm and Prim's algorithm, all concept comes under DFS. Okay, this is level by level searching. BFS itself can be used to detect cycle in a directed or undirected graph, find the shortest path in an unweighted graph. So BFS means it is very clear, it is very shortest path. It doesn't take more time for traversing, it is shortest path. So for example, you consider this is a graph structure, okay. So this start from 0, breadth versus search in a graph. So where we are having 1, 2, 0, 2, 0 length adjacent 1, then 3, 4, 2, 2. This is we are having a different graphs. So BFS first start with the my source node 0. Starting from 0, the BFS traversal proceeds as follows. First visit 0, then visit 1 because this is the immediate neighbor node 1. So neighbor of 0, 0.1. So this is my current source node is neighbor node 2. So again I visit 2. This 0, 2 neighbor, this is 1 and 2. I visited 0, 1, 2. Second, first neighbor of 2, this has not been visited. This is here 2 having unvisited node 3. Okay, so 0 having 2 neighbor node 1 and 2. So 0, 1, 2. Again 2 is our current node. It having the 2 neighbor node 3 and 4. So first visited 3, second visited 4. So output 0, 1, 2, again 3 and 4. Okay. So how we can use this traversal? It is a level by level based on immediate adjacent node. 0 it's adjacent node 1 and 2. Now 2 having 2 adjacent 3 and 4. So BFS 0, 1, 2, 3. This is our traversal. Then DFS or a graph, we traversal all adjacent vertex one by one. When we traverse an adjacent vertex, we completely finish the traversal of all vertex reachable through the edge adjacent vertex. We can traversal full level, full adjacent vertex, then you come back again, you can take the next level. This is similar to pre-order traversal in binary tree. So for example, this is the same representation. The source vertex is 0, we visit it first, then we visit its adjacent. So start at 0, it is marked as visited, so print 0. So again we are going to traversal 1, mark as visited, print 1. Again 1 means it is adjacent node 2, so 2 mark as visited, print 3, backtrack to 2. We are here 0, 0 means how we can represent this? So 0, 1, 2 we are having 3 and 4. This is the structure of this particular graph. So first we are traversaling 0, then 1 doesn't having any child node. Okay, then we are going back track to our source node 0, having another one child node 2. So we are traversaling 2. Again let's go for left side, it having the child node 3. We print 3. 3 doesn't having any child, then you go back to backtrack of 3's parent. So backtrack to 2 having another one child 4. So 0, 1, 2, 3 and 4. Here DFS we are having the concept of backtracking. So backtracking, why we are going for backtracking? Because DFS not level by level, it is going deepest until our leaf node, it should traversal, then we come back to parent node this is backtracking, then traversal the right side of the child. So this graph is represented as like this. Okay, so this is DFS. Next we are discuss about time complexity. How much time we are taking for both traversaling BFS and DFS. For breadth first search, time complexity, this is it is the notation of big O of vertex plus edge. How many vertex I am having in this particular graph and how many edges I am came through for traversal. So time complexity big O of V plus E. Axillary space big O of V. V means vertex only, not edges. So BFS we cannot having the separate memory axillary space. Just level by level we are traversing. We cannot having axillary space for edges. Time complexity for DFS big O of V plus E. Axillary space is same big O of V plus E. Here we are adding edge because we are having another one data structure for maintaining separate memory. This is visited array because we are going the concept of backtracking. So once you are visited, there should be mark as visited in visited array structure. That is after by some extra memory. So this is called the axillary space in DFS. So time complexity big O of V plus E. This is also important for problem solving. So representation of graph, we have two representation, axillary list and axillary matrix. So BFS and DFS, this is the traversal. So here we are going to represent the graph in the form of adjacent matrix. Example, so this is the directed graph. How it can be represented? This is axillary matrix. So the each node should be represented as an array 0, 1, 2, 0, 1, 2. This is node. Okay. Then based on this directed graph, the value should be filled in this matrix. So 0, it doesn't have any arrow, outlet arrow. So 0 and 0 no connection, 0 to 1 no connection, 0 to 2 no connection. So this is empty. Then you are concentrating 1 having the connection to vertex, another one connection to 0 node. So 1 to 0 is marked as 1, 1 to 2 it is marked as 1. Then node 2, it having the connection to node 0. So from 2 to 0 it is marked as 1. Okay, this is axillary matrix structure. So next one, axillary list. So this is a list format. List is in the form of array. Array index should be noted as the vertex 0, 1, 2. Same like this. 0 doesn't have any outlet direction, so it is empty. Then is followed by linked list. So 1 is having the connection between 2 and 0. So 1, 0, 2 again doesn't having any value. This is called as null. 2 means having only one connection 0. So 2 having the connection between 0 then followed by null. So array and linked list connection is used for representing directed graph. So this is called adjacent list. So graph representation, adjacent matrix and adjacent list. This only for representation. Easily understand the graph structure. If it is you are going for a very big graph, means we want to understand the structure of the graph. That's the purpose only it is used. So array matrix, it is in the matrix format, row and column. Array adjacent list in the form of array and linked list. So next we are going for the problems. So hope you understand the concepts. What is graph types and representation, traversal, BFS, DFS. Then only we can go under this concept. So first we are discuss the problems one by one. So first problem, consider the tree arcs of BFS and traversal from a source node W in an unweighted, connected, undirected graph. So I told you when we are discussing about types, basic terminologies of graph. The terms concept is very clear, then only we can solve the problems. Here key concept BFS traversal, then unweighted, connected, undirected. This is all key terms. The tree formed by the tree arcs is a data structure for computing. So this is a statement. Out of this statement, which option is correct? Consider the three arcs of a BFS traversal. So it's a level by level traversal. From source node W is an unweighted. We are start from W. It is connected, unweighted, and undirected graph. So for example, it's W is a W, then for example U and V. This is the graph structure. It is unweighted, doesn't having any weight, it is connected, and it is undirected graph. So the tree formed by a tree arc is a data structure of computing, which is the statement is right. Option correct answer is B, because the shortest path from W to every vertex in the graph. I already told you our key concept BFS traversal. BFS means very clear. This is its shortest path because it traversal level by level. So very clear, it is the shortest path. So three options are under shortest path. From W is our source vertex, to every vertex in the graph. Yes, BFS traversal, it first travels W, then it goes to second level. This is level 0, this is level 1. You go to traversal U and V. So to every vertex in the graph is a very correct, clear word. First one is also shortest path, but it is a every pair of vertex. It is not in between U and V. It is every vertex in the graph, not every pair. Okay, so it is clearly U shortest path from every vertex in the graph. This is option B. Second question, traversal of a graph is somewhat different the tree, because yes, it is somewhat different from tree. Traversal already we are discussing too. This is BFS and DFS. It is totally different from tree, because tree doesn't form any cycle, but graph it form a cycle. So correct option is A. There can be a loop in a graph. Loop is also called a cycle. So there is a difference between tree and graph. So we must maintain a visited array or visited flag for every vertex. This is the difference between tree traversal and the graph traversal. Then third one, what are the suitable data structures for the following algorithms? First algorithm, breadth first search. Second, depth first search and Prim's algorithm. And fourth one, critical minimum spanning tree algorithm. So option is second one. This is queue, stack, priority queue and union find. Breadth first search is level by level. It follows the queue. This is first in, first out. So first we are visiting, for example, if you are taking graph like W, U and V, first we visit W, second you visit U and V. So this follows queue, this is first in, first out order. Second, stack, this is depth first search, it first follows stack structure. Second, Prim's minimum spanning tree, it is follow the priority queue, it is taking the minimum weighted edge first. If it is having the edge, this is 1 and 2, then it should concentrate which edge is having the minimum weight. So we are giving the concentration first as W to V, W to U. So priority queue. Last algorithm, union find. Union find algorithm means you are first to find out the minimum weight, then you can find out whether the particular graph form a cycle or not. So you are going for union find for this algorithm. So option B is right answer for this question. solution. So queue is used in breadth first search, stack, priority queue, and then union point. So next question, BFS. So this is a BFS. You want to find out the BFS for this particular graph. Which option is correct one? First one, consider n is the source node. If n is the source node, we can find out the adjacent node as Q, M and O, but here P. So this is the wrong answer. We cannot go through it. Second, B, option B, Q is the source node. So adjacent node is M, N and P. But here is not coming O, because Q's immediate adjacent is M, then M immediate adjacent is R. So here Q, M, N, P is right, but O is come after R only. So this is wrong answer. Again I am going to C the right answer. Yes, Q having the immediate adjacent M, N and P. Then from M it goes to R, then P to O. So option C is the right answer for PFS traversal for a particular node. So next question, which of the two traversals, this is BFS or DFS, may be used to find if there is a path from S to T given two vertex in a graph. Yes, if there is any two vertex having a path, for example S to T, it having any edges, then definitely we can go through both BFS traversal and DFS traversal. So both BFS and DFS is the correct answer for this question. If it is any path in between any two vertex, we can traversal BFS and DFS. The statement written below is true or false. So if a directed graph DFS contains a back edge, any other directed graphs DFS will also have at least a single back edge. Yes. So if it is a directed graph, means it forms a cycle. Cycle means it is a back edge. We are going back edge. Then it is formed a cycle. This is true. A cycle in a graph is called as back edge. If it is, for example, W, U and V, this is a two traversal we are taking, directed graph, W, U and V, we are giving a direction. Back edge, first if it is DFS, first I will see W, then U doesn't have any child node, so again I am going back edge. This is called the back edge. So we are going to back edge, then again I am going to traversal B. So W, U, V, we are going for back edge. So if it is a directed graph, we are going for a back edge concept. This is true. So hope you students understand all the concepts under this graph. I am only concentrating basic ones. This is traversal, this is BFS and DFS types, and how we can represent the graph in the form of adjacency matrix and adjacency linked list concept types. So very important. So you go through all these with the concepts explanation, then only we can clearly get the concepts. Thank you students. So we will meet again the next video series under the another one concept. Thank you so much for your opportunity. Thank you.